Hello and welcome to yet another South Korean college scholastic ability test video. Today we will solve the following problem. Suppose that on a highway, vehicles are all traveling at the same speed v meters per second without changing lanes. The minimum distance between two successive vehicles considering the braking distance can be expressed as fv, which is 1/20 v squared plus 1/2 v plus 5 meters. So assuming that all vehicles are maintaining this minimum safe distance, what is the maximum number of vehicles that can pass through a certain point in a lane in 60 seconds? So before we actually formulate anything, let us take a closer look at the problem itself and understand why the maximum occurs in the first place by taking a look at two extreme cases. The first case is when the speed v is very small, which means that vehicles are moving at a very slow speed, and the second case is when v is very large, which means that vehicles are moving at a very fast speed. First, when the speed v is very small, then the safe distance fv also must be very small, meaning that vehicles can travel while being much closer to each other. However, despite this advantage in distances between vehicles, the number of vehicles passing through a certain point during certain time interval will be still very low because the speed of each vehicle is just too slow. On the other extreme, where the speed v is very large, now the traffic has clear advantage in terms of speed. However, as v increases, the distance fv also increases, meaning that vehicles must maintain much longer distances between them. In fact, fv is given as a quadratic function of v, so the larger the speed v becomes, the impact on the distance fv must be much more severe. So in this case, the number of vehicles passing through also remains low, because now the distance between vehicles becomes way too large. Therefore, there must be some kind of sweet spot for v, where the maximum number of vehicles can pass through. So now that we've understood how the maximum occurs, let's calculate that maximum number. So obviously, we have to find the expression for the number of vehicles that can pass through a certain point, which can be called the reference point, in 60 seconds. So let's call that variable n60 with the unit of vehicles. Now let us do some reverse process. What should we obtain in advance to calculate this n60? Well, obviously, we need an expression for the number of vehicles that can pass through the reference point in 1 second, the unit time interval. We can call it n1 vehicles per second. Then, n60 can be obtained by just multiplying 60 to this n1. Now, what do we need in advance to calculate this n1? Well, we need to know how long it takes after one vehicle passes a certain point before the next vehicle passes that point. If we call this time interval between two vehicles passing through the reference point delta t seconds per vehicle, then n1, the number of vehicles passing through the reference point per unit second, is simply the reciprocal of this time interval. So let us calculate this delta t. At the moment one vehicle passes a certain point on a lane, the next vehicle is fv meters behind. So the next vehicle has to cover the distance fv in order to get to the reference point, and since vehicles are moving at speed v, the time it takes to travel the distance fv is given as the distance fv divided by speed v. So using the given expression for fv, we have 1/20 v plus 1/2 plus 5 over v. Therefore, n1, the number of vehicles passing through per unit second, is given as the reciprocal of delta t, so 1/20 v plus 1/2 plus 5 over v. And n60, the number of vehicles passing through per 60 seconds, is given by 60 times n1, so 60 over 1/20 v plus 1/2 plus 5 over v. So we need to find the maximum value of this function of v. Here, we have v term and 1 over v term, and we know that v is positive, which means that this is a perfect opportunity to apply the famous arithmetic mean geometric mean inequality, which is this. Here, the terms are in the denominator, so we have less than or equal to 60 over, first rewrite 1/2, then 2 times square root of 1 over 20v times 5 over v, and here the equality holds when 1 over 20v equals 5 over v, so v squared equals 100, so v equals 10 meters per second. Here, cancelling out v, we have 60 over 1/2 plus 2 times the square root of 1 over 4, and this square root of 1 over 4 is 1/2, so it can be cancelled, which gives 60 over 1/2 plus 1, which is 40. Therefore, the maximum number of vehicles that can pass through in 60 seconds is 40, so the correct choice is choice 2. And that was all for today's video. If you enjoyed this video, please give it a like and also subscribe to my channel, and I will see you in another video.